Okay, I know I lied, but you know what? I don't care. Because by request, you have now been presented with a video, this video, that will look at the reversion of the Michael reaction. Let's say that this is the product that we want to end up with, and we want to know what starting reagents that we need in order to get to that route. So you know that these types of questions might be on some type of homework assignment, it might be on some type of an exam, but this is a product now on the screen, two different products that we want to make using the Michael reaction. And we have to figure out what two pieces of the puzzle we need in order to bring these two things together. These are probably easier than starting with the reagents, what product is formed, because I can quickly look at this product and split it into two pieces and automatically tell you what's going to happen here. So if I take a look at A, well, I know that I'm going to have some type of dicarbonyl group as one of my products, and the other product is going to have to be a carbonyl with a double bond in it. So the very first thing that I do is I look for two carbonyls that are basically separated by a carbon, because that's going to be one of the pieces to the puzzle. So if I look at this product here, well, I can automatically figure out here is the C double bond O, there's a C double bond O, it's separated by one carbon. So this is probably one piece that I have used in the Michael reaction, and it has a hookup spot there. So I'm just going to kind of take that and just draw a line and say here are my two halves. Okay, so my first half is going to include this carbon, CH, and the carbon next door is a C double bond O with a methyl group on it. And on the other side is a C double bond O with a methyl group on it as well. And this CH group, well, I know that we've drawn it CH here, but it was initially a CH2 because we've incorporated a base to pull that hydrogen off so the hookup spot can be at that location. So there is one half of the products that I need, plus, well, this is going to tell me the other half. I get a ring involved here with the double bond O, and it's looking like it's here at this carbon. Okay, so at this carbon, if this is where the hookup is at, that is my beta carbon. So my beta carbon and alpha carbon share a double bond. And that is the reagent that we will use for the alpha beta unsaturated ketone here. So there are the two pieces that I need to bring together in order for this product to go forward. The only thing that I'm missing is the presence of some type of base. So this can be OH minus or OCH3 minus something. It's got to be a base there though. Okay, well, what about the bottom one? Is this one any more difficult? And the answer is no. It looks like a little bit more complicated molecule, but determining the pieces that need to fit together to make this work, there's no difference in what I do here than what I've done up above. So I'm just going to take a look at this molecule and try to find two carbonyls that are separated by a carbon. And look, here's one carbonyl, C double bond O. There's a C double bond O separated by one carbon. So that probably means that that is the hookup point. That's the hookup spot, right? So with one of these products, I've got a carbon with a hydrogen right here. To the left of it, or whatever the case is, a C double bond O. And then that's connected to an oxygen. That's then connected to an ethyl group, CH2 and CH3. Well, I'll do the same thing on the other side. On the other side, I see a carbon double bond O. Then that's connected to an oxygen, and that oxygen's connected to an ethyl group. So CH2 and CH3. So there's one of the products that's required for the Michael. Okay, the other piece is going to be here, so I'm just going to redraw that like I did from up above. And this is a double bond O, right? So 1, 2, 3, and 4 carbons. So 1, 2, 3, and 4 carbons with a double bond O. That means that this was my beta carbon, which means that my alpha and beta carbon needed to share a double bond at that location. So a double bond is going to be here. And there's the two pieces for Machel, excuse me, for the Machel reaction. And for it to go forward, I need a little bit of base to make this better. So OH minus. Okay, so now I promise that we can go on to the next video. The next video is going to be another type of reaction that's going to be happening at the alpha beta carbons like we've always seen over and over and over. And this is going to be called the Claisen condensation. So this is kind of where we're going to stop with the videos for type 3 carbonyls. So the Claisen condensation will be the last reaction that we will cover. If you go to the textbook and you look at some of these other reactions that are involved, we're not going to be talking about those. We're not going to be focused on those types of reactions. So the next video, that's going to be it. And we are finished with carbonyl reactions.